Hi, this is the complete lesson in work, energy and power focused on Edexcel IAL Unit 1 syllabus. See the description of this video, there are all the necessary and useful links related to my other videos are given. Also by using playlists of this channel, you can navigate to any video you want. Okay, so work, energy and power, the same topics you had in IGCSE also. Actually, when you compare the IGCSE syllabus and A-level syllabus, there is not much differences related to these topics. Almost the similar topics, or even the theory, equations are almost the same. But the questions in A-level are a little bit challenging. The only different equation compared to IGCSE, uh, power equal to force into speed. That's the equation not in the IGCSE syllabus, but A level we use, but it's not a big issue. Other than that, in A level there could be questions related to elastic potential energy and kinetic energy, elastic potential energy and gravitational potential energy. Those type of questions also could appear in A level, but I already discussed questions related to elastic potential energy in my lesson named solids. So there you can see those questions. Okay, so what is work? You know, in physics, when we define a physical quantity, most probably it's defined in terms of an equation. So work is defined as force into distance moved along the direction of force. That's the way we define work. So normally students they ask, say work is defined as work equal force into distance moved along the direction of force. So here just a multiplication, numerical multiplication. So students normally they ask, is it a vector quantity or scalar quantity work? Because force is a vector, distance moved along the direction of force we say, so it's a scalar, distance is a scalar. So when you multiply a vector by a scalar, it should be vector. No, actually work is a scalar quantity, it is not a vector quantity, because one reason openly we can say work never obeys vector addition rule. Work never obeys vector addition rule. Also we can say actual mathematical definition of work is given in terms of dot product. You know, when we multiply two vectors, there are two different types of vectors are there. It's actually, I think in further mathematics you would have learned, not in physics, but I'll little bit touch about it. There are two different types of vector multiplications are there. One is called cross product or vector product. Other one is called dot product or scalar product. Say for example, if A and B are two vectors, the dot product of two vectors are given mod A times mod B into cos theta. So mod A is the modulus of vector A, the magnitude of the vector A. Modulus B is the magnitude of vector B. Cos theta, theta is the angle between two vectors. Say if the vector A is along this direction, vector B is along this direction, theta is the angle between them. So theta is the angle between the two vectors. So you can see the outcome. These two are vectors, they are multiplied, but the outcome or the results is a scalar, because modulus A is a scalar, modulus B is a scalar, cos theta is an angle between the two vectors, it's a scalar. So this quantity, after you multiply two vectors, it becomes a scalar. Same way, here also the work is defined as, you know, work is defined as force dot, actually force is a vector dot, distance is a vector, we take the displacement, actually the shortest length moved by the force F. So actually distance is a vector, mod F, mod D is the actual definition. So it will be vector F dot vector D is the actual definition. It will be mod F into mod D into cos theta. So for example, I'm going to give you a few examples. Say for example, if something like a box is pulled along the direction of motion, the force is applied along the direction of motion, the box is moved in this direction, something like this. This is the distance moved d. So both are parallel vectors. The angle between them is 0. So cos 0 is 1. So work is given by F into d. F into d, the multiplication of the two magnitudes. F into d is a scalar quantity. But if the force is something like you are moving a traveling bag, you are pulling a traveling bag. So something like traveling bag. I'll give the examples again, just I am showing it. Pulled along by applying a force of theta to the horizontal, but the traveling bag is moving along the horizontal direction. Distance d means here the work is defined as, I call it mathematically, F dot d, that is mod F mod d cos theta, the angle between the two vectors. So the theta, this is d is along the horizontal direction is the d. So the angle F, the force F is taking an angle theta with the horizontal direction. So mod F mod d cos theta. That's the reason your teacher would have said Fd cos theta. That's the way you write the work done here. We consider the force along the direction of motion. You would have learned like this. Anyway, but this is the reason, actual definition of work, dot product. But we don't consider that. Just for students, those who are asking whether work is a vector or scalar, for them only I explained it. So here, even I put cross, I am multiplying the two magnitudes, magnitude F and magnitude D. Otherwise, if the F and D are in different direction, we should consider they are parallel compounds. I'll give you a few examples, then you will come to know that. Remember that work is a scalar quantity. It is not a vector quantity. Remember that. Okay, so here I showed a few examples related to calculating work in your syllabus without using any dot product. That is not in your syllabus. I just used it to explain why is it a scalar quantity. Work is a scalar quantity, not a vector quantity. But just you don't need to remember that dot product, that is not in your syllabus. Okay, so we'll come back to the actual syllabus. We define the work in your syllabus. Work equal force into distance moved along the direction of force. Okay, first diagram, an object, a box or something is pulled along a horizontal surface by applying a force F. Here the force is a constant always. We don't consider variable force. It's a constant force, remember that. So force is a constant. The distance moved along the direction of force is d. So work done equal F into d. First example. Second example, something like pulling a traveling bag. The force is applied on the handle F at an angle theta to the horizontal, but the bag is moving on a horizontal flow a distance d. So work is defined as force into distance moved in the direction of force. So force is at an angle theta to the horizontal, but the distance moved is along the horizontal direction d. We need to consider both in the similar direction. There is no motion along the direction of force, but there is a component of force along the direction of motion, which is F cos theta. So work done by the force F cos theta into d. Here also work done by the force. Force is doing work. Force is doing work. So W equal F into d, because F and d are parallel. But here we need to consider the component of force along the direction of motion, that is F cos theta into d. The third example, an object, something like a box, is pulled along a slope by applying a force F parallel to the slope. The distance moved along the slope or parallel to the slope is d. So their work done by the force is force into distance, because force is applied along the slope. Motion also along the slope up distance d. So work equal F into d. Work done by the force F. Here an object of mass m is pulled upwards. The weight is mg. So the minimum force required to pull the object through a height h is mg, minimum force. If you apply more than mg, yes, the object will accelerate because there will be a resultant force in upward direction. But if you apply a force F which is equal to mg, the resultant force 0, so it will move at constant velocity vertical direction upwards. So they are the work done by the force F is equal to force into distance moved is h, so that is mgh. Later I'll explain this is the gain in gravitational potential energy. Work done will become gain in Gp, but I'll come to that point. But here the work done is equal to mgh. Okay, I gave already 4 different examples related to work done. This is also something related to work done, but slightly different. This is called work done against friction or drag force. So work done against friction or drag force is given by against friction. That means an object is moving towards right. You know, friction or drag that acts opposite to the direction of motion. So it will act opposite to the direction of motion. But the object is moving along the direction of motion. It moved a distance d. It's moving to the right, distance d. The friction is acting opposite to the direction of motion. That is, friction is acting towards left. So work done against friction, that also given as friction force into distance moved. So work done against friction is given by friction force into distance moved opposite to the direction of force. So these two quantities will be in opposite direction to each other. Okay, so work is equal to force into distance moved along the direction of force. So unit of work is equal to unit of force into unit of distance, Newton meter, that is given in SI unit as joules, denoted by capital J. We can give the joule in base units. Joule is equal to Newton meter. Newton is kilogram meter second minus 2 into meter. So that is kilogram meter squared S minus 2 is the unit of joules in terms of base units. SI unit is joules. Okay, what is energy? Energy means physical quantity that can do work, or the ability to do work is called energy. Unit of energy is also same as unit of work, which is joules as in SI unit. Okay, so there are different types of energies you learned in IGCSE. I am not going to repeat, but in A level energy related to calculations related to energy, there are only certain things only we consider. For example, first we consider kinetic energy. You had it in IGCSE also. First one is kinetic energy. This is the energy possessed by a moving object due to its mass and speed, half mu squared or half mv squared. We can use m must be in kilograms. It must be in kilograms. U must be in meter per second. So the unit of kinetic energy will be joules. Okay, so when the speed of an object increases, what will happen? Kinetic energy will increase. We call it as gain in kinetic energy. When the speed increases, kinetic energy will be gained or will be increased. So we say gain in kinetic energy is equal to final kinetic energy minus initial kinetic energy. That happens when an object accelerates, when the speed increases. When the speed increases, its kinetic energy will increase. We call gain in kinetic energy. So gain in kinetic energy, how do we calculate the numerical value of gain in kinetic energy? Final kinetic energy minus initial kinetic energy. That is general notation, half m v squared. We use v for final speed. So half m v squared minus half m u squared. Same way, when object decelerates, slows down, its kinetic energy will decrease. There we call loss in kinetic energy. Loss in kinetic energy. Loss in kinetic energy means for initial kinetic energy minus final kinetic energy. Kinetic energy we can shortly write k dot e dot. So initial kinetic energy half m u squared minus half m v squared. This is the loss in kinetic energy that happens when an object slows down or decelerates. When an object moves at constant speed, there is no change in kinetic energy. The change in kinetic energy will be equal to 0. That you know that. So this is the first equation for energy. in your syllabus. There are more equations related to energy. Okay, so next thing is gravitational potential. You had it in O level, but in slightly confusing way we tell in O level, because you know you can't measure the gravitational potential. You can, then you must know the radius of the planet. For example, if you are measuring the gravitational potential energy of an object kept on the surface of Earth, you should know the radius of the Earth. So the gravitational potential, you learn that in O level, mgh, yeah. So mgh you learn that in O level, but that is not the gravitational potential. What you learn in O level, mgh, where what is h, first you should identify. You can measure the gravitational potential energy by considering from the center of the Earth, the distance must be considered from the center of the Earth. We calculate that way in Unit 5 under gravitational field. In Unit 5 under gravitational field, topic called gravitational field, we calculate the actual actual gravitational potential energy of a satellite, actual gravitational potential energy of a object. There, the h, what you learned in O level mgh, h is calculated from the center of the planet. But in Unit 1, what we learned here is either gain in gravitational potential energy or loss in gravitational potential energy. We can't measure the gravitational potential energy from the surface of Earth. For example, consider like this. For example, this is the ground. An object of mass m is here. This is the mass of the object m. The center of mass, we should always measure h from the center of mass if the dimension of the object is reasonably larger. If the object has negligible dimension, we don't consider the center of mass. Okay, imagine there's an object which has mass m. It is at a particular height above the ground. This is the ground. The object is moving up. The object is moving up from this position. The center of mass is this is the center of mass. So the height it moved is h. The height it moved is h. So there we consider gain in gravitational potential energy. Gain in gravitational potential energy equal to mgh. So what is h here? We are not measuring from the ground. We are not measuring from the ground. H is the height through which it moved. H is measured from center of the mass of the object to center of mass of the object. But if the dimension of the object is negligible, we don't consider center of mass, just we measure the distance moved up in this equation. So h is the vertical distance. Careful, h is the vertical distance. H must be vertical distance moved from the initial position to final position. It is moving upward direction, so we say gain in gravitational potential energy. Same way, an object is falling down. This is the initial position. This is the final position. The ground may be somewhere here. We don't need to consider the ground. The height through which it falls down, the vertical height, careful, vertical height through which it falls down is h. Mass of the object is m. H is measured from center of mass to center of mass. If the dimension is considerable, but if the dimension is negligible, we don't need to consider the center of mass, just you can take the initial and the final positions. Okay, so the height through which it falls down, vertical height is h, so there we say loss in gravitational potential energy. Loss in gravitational potential energy equal mgh. Here h is nothing related to ground. We are not considering the ground here. Don't consider it should be measured from the ground. No. The height through which it moves up or height through which it moves down. Height means the vertical height. Okay, consider this example. An object of mass m is moving along or is moved along a slope that makes an angle theta with horizontal. So initially the object is here, not at the ground level, somewhere here. It's initially at this position, finally at this position. So along the slope it has moved a distance d. What is the gain in gravitational potential? Because it's moving upwards direction. So if it is gaining gravitational potential, I must be able to find the vertical height moved by the object. So center of mass to center of mass we should consider if we know the dimension. Otherwise just ignore the center of mass, just take the position of the object. So you can consider the positions of the object. This is the horizontal line. This is the change in vertical position h. So the distance moved is d. This is not mentioned, h is not mentioned. I am finding the h. This is the angle theta because they are parallel angle. This is theta horizontal, this is horizontal. So this and this are same angle theta. So the distance moved is d along the slope. So from here to here is d. So what is the height h? We know that sine theta equal to h over d. So h is equal to d sine theta. Is it? In this right angle triangle, h over d is sine theta. So h is equal to d sine theta. So here gain in gravitational potential energy, the object is moving up. So gain in gravitational potential energy is equal to mgh. H is the vertical height. We must consider vertical height. So mg, but h is not given. Only the d is given. It's moved along the d. So h should be given in terms of d. So mg d sine theta. That is the gain in gravitational potential energy. Okay, so here the object is sliding down on a ramp that makes an angle theta with horizontals moving down. So they are also the same thing. It moved down along the ramp distance d. The angle is theta. So sine theta same as h over d. So h is equal to d sine theta, same mathematical approach. Here it's moving down. So we say loss in gravitational potential energy equal to mgh. Loss in gravitational potential energy. Loss means h is going down vertically, height moved down from here to here. The vertical height it moved down is h. So mgh. What's the vertical height? It moves down is the h. So loss in gravitational potential energy equal mgh. So that we can write mg d sine theta because h equal d sine theta. Imagine a situation where a trolley is moving on a curved track, So the distance it moved we don't know, but we know when it moves from this position to this position, the vertical height it has fallen is h. The vertical height from this position to this position, the trolley is moving along the curved track. So during the time, the vertical height it has fallen downward is h. So there we can say loss in gravitational potential energy equal mgh. Okay, imagine a small sphere of mass m is attached to a light inextensible string L, length L, and the other end of the string is attached to a horizontal nail or something. Initially the string is held in horizontal position under tension and released. So the sphere is moving down on a part of a circle, 1/4 of the circle. When the sphere comes to the lowest position, the string will be in vertical position. It's a light string. The string is in vertical position. So they are lost in gravitational potential energy. The sphere is moving down. The string has no mass. It's a light string. So initially it was in horizontal position. The string was in horizontal position. So when the sphere comes to the lowest position, the string will be in vertical position. So loss in gravitational potential energy equal to mg. The vertical height the sphere has fallen. Initially it was here, finally here. The length of the string is L means mgl. Again, power equal work done over time. So work is given by F into D over T. So F into D over T, D is the distance moved. That will give the constant speed if the object is moving at constant speed. If it is accelerating, we don't consider much that type of thing in your syllabus, because if it is accelerating, then we should consider the average speed. But normally your question is something like object is moved on a horizontal plane by applying force F, and there's a friction Fr. F equal Fr means it's move at constant speed. That speed is V here. So here this is the power loss against the friction or power generated to move at constant speed. Either way we can interpret this power. Okay, so the next thing is efficiency, that also you had it in IGCSE. Useful output work over input work or input energy. Either way we can say input work or input energy. Normally we say input energy into 100%. Or you can say useful output energy over input energy. Either way, depending on the situation, into 100%, or useful output power over input power. In terms of power also we can say into 100%. These things you had it in IGCSE also. This gives the efficiency. So the next important topic you had it that also in IGCSE, the law of conservation of energy. That means energy cannot be created or destroyed, but it could be converted from one form of energy to another form. So your calculations are based on the law of conservation of energy. You should be able to identify the type of transfer of energy from one form to another form. Then you need to write the relevant equations, then solve it. You will get the correct answer. So I'll do few questions related to law of conservation of energy. Those are the questions, calculations comes in your exam. So that's all related to theory. So we'll do few questions now. Okay, so this type of question, first question, a shopping trolley of mass 20 kilogram is pushed on a horizontal floor from rest. Force of 12 Newton is applied at an angle 20 degree to the horizontal. During the motion, total resistive force is 5 Newton, maybe on the axle over somewhere. 5 Newton is the resistive force. Find the speed of the shopping trolley when it moved through 10 meters. That means it's moving horizontally. So we can answer this question by using energy equation, as well as we can get the same answer by using Newton's second law, F equal ma, and equations of motion. I'll show both methods. First I'll do by using energy equation. So first we'll need to find the energy equation, proper energy equation. That means based on the law of conservation of energy, you should be able to identify the relevant relationship between energies. Okay, so here what's happening, a force is applied 12 Newton by the person at an angle 20 degree to the horizontal, and he is moving through a distance of 10 meters. It's moved through 10 meters. So there is work done. Work done is equal to force into distance moved. Okay, so because of that work done, that means the person who is pushing the shopping trolley is losing his chemical energy. All level we learned that when you do work, you will lose your chemical energy. So the work done by the person will be converted into some other format. What are the other formats? The shopping trolley totally including the contents 20 kilogram. So totally the shopping trolley and its contents are gaining kinetic energy because of the work done by the person. Additionally, something is also happening. There is friction. So due to friction, there will be heat and sound produced. We don't say heat energy, sound energy. We don't have equation for that. That is called work done against friction. Because of work done against friction, sound and heat are formed. So the three things are happening that you must be able to identify what type of energy transfer, how to relate them. That is your skill. You should be able to identify. First, I can say the person is doing work when he or she pushes the shopping trolley. That is force into distance. We need to find the horizontal component of the force. That is 12 cos 20 into distance moved is 10 meters. That is the work done. Because of work done, all the work done won't be given as kinetic energy. A certain amount of energy will be given as kinetic energy, and balance will be used to do work against friction. So I can relate that all these three things, work done by the person or work done by 12 Newton by 12 Newton force. Because of that, the shopping trolley is gaining kinetic energy, plus sound and heat are formed. We don't put sound and heat, that we say work done against friction. So in case if there is no friction, this we don't write. We will say work done by the 12 Newton force equal gaining kinetic energy. That's all if there is no friction. But here there is friction, resistive force. So there will be sound and heat. We don't write sound and heat are produced. We say work done against friction. So work done by the 12 Newton force is F cos 20. That is 12 cos 20. That's a force component parallel to the direction of motion into distance moved. Distance moved is 10. Force into distance moved. Gaining kinetic energy, final kinetic energy, half m, the mass is 20 kilogram, into v squared minus, initially it was at rest, pushed on horizontal flow, trolley mass from rest. So initially it has no kinetic energy. So gaining kinetic energy, final kinetic energy minus initial kinetic energy. This is the gaining kinetic energy. Plus work done against friction. Work done against friction means friction force. We know that 5 Newton, that acts opposite to the motion. Friction force into distance moved 10. That's all. So everything you know except we solve it, you will get the v. That will be the speed when it is pushed through 10 meters. You will get 2.51 meter per second. Okay, so here they did not ask by using energy equation. So you can do this type of equation either by using energy equations or by using Newton's second law and equation motion. I am going to do that. But in case if they ask by using energy equation, answer the question, or by using energy equation find the speed, means this is the only way you should do. But here nothing is mentioned. So I can do by using Newton's second law and equations of motion also. So the second method is the first method. Second method, F equal ma we'll consider. So the force applied by the person in horizontal direction is 12 cos 20 minus the friction is 5. That is equal to ma. The mass is 20 kilogram. 20 into a. Find the acceleration. That is going to be 0.314 meter per second squared. Now it was at rest and the acceleration is constant because all forces are constant, they are not changing. Therefore I can use equations of motion. V squared equal u squared plus 2as. The final speed I need to find, it was at rest, starting from rest, 2 times acceleration I found it 0.314. The distance moved is 10. Solve it, you will get the same answer as here. So either way we can do. Okay, so this is the second question. A box of mass 2 kg is projected on a horizontal flow at a speed of 12 meter per second. During its motion, total resistive force acting on it is 6 Newton. So a box of mass 12 Newton is flown on a float, horizontally thrown at a speed of 12 meter per second. So during the motion, it experiences a friction of 6 Newton. Find the speed of the box when it moves through a distance of 10 meter. That's a horizontal flow, 10 meter. Okay, here also you can do in 2 different ways. First is by using energy equations. Second one by using Newton's second law and equations of motion. So method 1, here you should be able to identify the change in the relationship between the change in energy, or what type of energy is lost, what type of energy is gained. So it's thrown horizontally. Initially there's a speed given. When it moves due to friction, it will slow down, means it's going to lose kinetic energy. So losing, it's moving on a horizontal flow. There is no change in gravitational potential energy because it's moving on a horizontal flow. So there is no change in gravitational potential energy. because there's no vertical change in height. So only simple loss in kinetic energy. It's going to lose kinetic energy. What's going to happen? Loss in kinetic energy will become heat and sound due to resistive force. But we don't say heat and sound. We say loss in kinetic energy equal work done against friction. Work done against friction. So loss in kinetic energy means initial kinetic energy half mu squared minus half mv squared equal Fr times the distance moved, Fr into d. So mass of the box is 2 kilogram, half into 2 into initial speed is 12 squared minus the final speed we need to find it v squared, we need to find the v, is equal to friction, that is 6 into the distance moved is 10. Solve it, you know everything, solve it, you will get v, that's the speed when it moves 10 meters, v will be equal to 9.17. So we can find by using Newton's second law and equations motion, that is the method 2. So this direction, along the direction of motion, if I use F equal ma, the only force acting is friction opposite to the motion. So minus 6 equal mass is 2 into A. So from this A is going to be minus 3 meter per second square. So we know that opposite to the direction of motion, acceleration is acting opposite to the direction of motion. So it's going to be a deceleration. Then use V squared equal u squared plus 2s because constant deceleration and moving on a straight line. So v squared equal u squared plus 2s. You should know the condition to use the equations of motion. Acceleration must be constant and the motion should be on a straight line. So initial speed is 12 squared plus 2 into minus 3 into 10. Solve it and find the v. You will get the exactly same answer. Okay, so the third question, box of mass 10 kilogram is pulled upwards from rest along a slope by applying a force of 25 Newton. The slope makes an angle of 12 degree with horizontal. Total resistive force on the box is 2.8 Newton. Find the speed of the box when it is pulled through 8 meters along the slope upwards. Okay, so here also we can answer two different ways. First method we are going to use energy equation. So something is pulling it, a person is pulling or animal or engine, something is pulling. So there is work done by 25 Newton. So work done by the 25 Newton will be converted into what type of other energies you should be able to identify. So there, otherwise you can't write the proper energy equation. So that you should have that experience to identify the type of energy transformations happening. Say for example, here work is done by a force of 25 Newton when it is pulled along the slope through 8 meters. So it's going to be what type of other energies you should be able to identify. Okay, so we'll see that. So here the next, for that we need to identify the other type of energies. It's moving on a slope. So first we should say work done by 25 Newton. Newton force. Then what's going to happen? The box is moving from rest. So its speed is increasing, otherwise it can't move. So there is gain in kinetic energy because of this work done. Gain in kinetic energy plus what other things are happening? One is gain in kinetic energy. The other thing is the box is moving upwards. Initially the box is at lower position, now it's going up through a height h. We should measure from the center of mass, but the dimension of the box is not given. So I can take from the right edge of the box to right edge of the box. So the height moved vertically upwards is h. I am going to find the h in terms of the distance moved 8 meters. We can find it. But we'll first write the energy equation. So it's going to gain in gravitational potential energy because moving upward direction, gain in gravitational potential energy plus what else happening? Sound and heat would have created because there is friction is acting. So work done against friction. Work done against friction, I put FR, friction. Okay, so work done by 25 Newton, force into distance moved, so that is F into distance moved, that I am going to find FD. I will substitute the values FD. Gain in kinetic energy half mv squared minus half mu squared. We will substitute the values anyway, u is 0, we are going to find it. Gain in GPE mgh plus FR into distance moved. D is 8 meters. We are going to substitute FR into D. I can put dot or cross whatever it is. We are considering the numerical values. So H, I need to find proper value. H means in this right angle triangle. This is 12 degree, means this is also 12 degree because parallel angle. So we know that sine 12 is equal to H over 8 when you consider this right angle triangle. So sine 12 is equal to H over 8. So that means H is equal to 8 sine 12. Use that one in the equation. So I'm going to write this equation again. Now I'm going to continue this equation. So F into D, force is 25 into distance moved is 8 equal to half into mass is mass of the box is 10 kilogram, 10 into V squared minus 0 because it's moving from rest. Pulled upward from rest, so initial speed is 0, initial kinetic energy is 0, plus mgh, this one, mass is 10 kilogram into 9.81, instead of h, that is 8 sine 12, plus work done against friction, friction force is 2.8, distance moved is 8, so 2.8 into distance moved is 8. Okay, that's all. Solve it. You will get the answer V. So V is equal to, solve it. All the numbers are there, only V is the unknown. Solve it and find V. You will get V is equal to 1.70 meter per second. Okay, so now I'm going to do by using the second method. If the object is kept on a slope, see my lesson related to force, separately I put it. If there's an object of mass m is kept, an angle is theta, the weight is acting vertically down mg. The component of the weight along the slope down is mg sine theta. I derived it there, see there in my lesson video related to forces. This is mg, sine theta is the component of the weight along the slope up downwards. So here the box is pulled along the upward direction. So I am going to use F equal ma, the method 2 I am using. So this is the method 2. This I just told. I am going to use this here also. So I am going to use F equal ma along the slope upward direction. What are the forces acting on it? It's pulled upward direction, so 25 Newton, minus the component of the weight is acting downwards. Mass is 10 kilograms, so the weight is 10 into 9.81. The component along the slope down means sine, mg sine, mg is this one, mg sine 12, minus friction also acting down. I am using upward direction, 25 is upward, so I wrote it positive. The component of the weight is down, that's the reason written with negative sign. Then the friction also acting down along the slope, that is 2.8. 2.8 is equal to F equal, this is the resultant force downward, upward direction, equal to mass of the box is 10 kilogram, 10 into A. Find the acceleration along the slope, upward direction. You will get acceleration that is equal to 0.18 meter per second square. Now along the slope upwards, not horizontal, along the slope upwards, use V squared equal U squared plus 2AS. V squared I need to find, U squared 0, 2 times, acceleration is 0.18, that we found it now, into S is 8. Find the V, take the square root of it and find the V. You'll get 1.70 meter per second. Same as earlier, you will get the answer. Okay, so this is the next question. Here two objects are in motion. An object of mass m1 is 10 kilogram. It's connected to an object of mass m2 which is 15 kilogram by using a smooth pulley and a string. Initially m1 is kept at a height of 2 meters above the ground and the whole system is allowed to move from rest. So m2 is at a slope that makes an angle 20 degree with horizontal. So here also we can find the speed. The question is find the speed of m2 when m1 just reaches the ground or just touches the ground. So here also we can do two different methods. First is by using energy equation. Second one by you finding the acceleration and equations of motion. Either way we can find. Okay, first one we'll use the energy equation. So first identify what type of energy changes are happening now. Okay, when we release the system from rest, what will happen? The 10 kilogram mass will move down. So that means the 10 kilogram mass will move down, means it will lose gravitational potential energy. Because it's losing gravitational potential energy, all other things are going to happen. That means this is going to move along the slope up. So this is going to gain gravitational potential energy. This is going to gain kinetic energy because the whole system was at rest and they are going to start to move. So that means this is going to gain kinetic energy. 10 kilogram m1 also going to gain kinetic energy. Then what's going to happen? There is friction acting between the slope and the m2, that is 3 Newton. So there will be sound and heat. So there will be work done against friction. So these are the energy transfer going to happen when the whole system is allowed to move from rest. So we'll start from what's good. So that you should be able to identify what type of energy changes are going to happen, right? Depending on the question, right? So here when the system is allowed to move from rest, this is moving down because 10 kilogram is moving down, the whole system is going to move because of the loss in GPE of M1. This is M1, this is M2. So we'll start like this: loss in GPE, gravitational potential energy of M1, that is 10 kilogram. Because of that, what's going to happen? Gain in kinetic, because this also initially at rest, now it's going to gain speed. So gain in kinetic energy of M1 itself going to gain kinetic energy. M2 is connected with a string, light string, inextensible string. So M2 is going to move from rest. So gain in kinetic energy of gain kinetic energy, or gain shortly I gain kinetic energy of M2 plus. Now M2 is going to move along the slope up. So gaining GP of M2 of M2 plus M2 is going to do work against friction. There is friction, work done against friction. Friction by M2, friction FR I put it. Okay, so these are the four things happening because of loss in GP of M1. Okay, what is loss in GP on M1? MGH, that is 10 into G 9.81 into 2. It's moving through 2 meters, so MGH. Right, gaining kinetic energy of M1, it was at rest, so half 10 V squared, it was at rest, 0. Gaining kinetic energy of M1. Gaining kinetic energy of M2, it was at rest, so plus half into 15 V squared. Both should have the same speed because light inelastic string in your syllabus. So since the string is inelastic, both should have the same speed. Half M V squared minus 0. There's a kinetic energy gained by m2. Gaining Gp of m2. So m2 is moving along the slope 2 meters, because when the 10 kilogram moves down 2 meters, the string will be pulled along the slope upwards through 10 meters. So what is the vertical height change? Imagine the box m2 or the object m2 will move, this is m2, will move along the slope upwards a distance of 2 meters. It makes an angle horizontally 20 degree means, what is this height h? If I consider this right angle triangle, sine 20 equal h over 2. So h is going to be 2 sine 20. That's a vertical height. The m2 is going to move along the slope when m1 touches the ground. 2 sine 20 is the vertical height. So mgh, work gaining Gp of m2 means mass of m2 is 15 into 9.81 into 2 sine 20 plus friction, work done against friction. So it's moving along the slope 2 meters, along the slope 2 meters, friction is acting opposite. So friction force, that is 3 into 2, right, that's all. So when you solve all these things, only one unknown, that is v squared. So here it will become 5v squared, here 7.5v squared, 5v squared plus 7.v squared, 12.5v squared, all others numbers, solve it, you know how to solve. You will get v is equal to 2.68 meter per second. Okay, so here also you can do by using Newton's second law and equations of motion, because the motion is on a straight line and constant acceleration. That's the reason you are able to use Newton's second law and equations of motion. If I draw the free body force diagram for m1, the forces acting on m1 are, the weight is acting downwards, m1g, and there is tension T due to the spring. If you think about the m2, what are the forces acting on m2? It's on a slope. So m2 is kept on a slope like this. So there the tension is acting upwards along the string. The component of the weight is acting down, that is m2g sine 20. And also there is friction acting opposite, that is 3 Newton. Okay, so I can use F equal ma separately for m1 and m2. This is figure 1, this is figure 2. For m1, if I use downward direction, F equal ma, m1g minus t equal m1a. Let it be first equation. Both should have the same acceleration, because string is inelastic. That's the way in your syllabus. If they are different acceleration, the string will be extended. So that's not happening. Inelastic string. That's the way in your question. So both should have the same acceleration. So for m2, if I use F equal ma along the slope up, t minus m2g sine 20 minus friction Fr equal m2a, second equation. Both should have the same acceleration. Okay, now physics over maths. I need to solve minus t plus t. We don't need. You can substitute instead of t m1g minus m1a, or just add the both equation. You know how to solve two equations. M1 first two equation, if you add it, minus t, t will get cancelled. You will get m1g minus m2g sine 20 minus Fr equal to t and t get cancelled, minus t and plus t. Right side m1a, m2a, so m1 plus m2a. Substitute m1g, m1 is 10 into 9.81 minus 15 into 9.81 sine 20 minus Fr is 3 Newton, friction is 3 Newton, so 3 equal to m1 plus m2, 15 plus 10, 25a. Solve it, find the a. So you will get a, acceleration will be equal to 1.791 meter per second square. Now use the equation v squared equal u squared plus 2as along the slope up. The acceleration we know that. So v squared I need to find, u squared 0, system is allowed to move from rest. Acceleration is 2 into 1.791 into distance moved along the slope up is 2 meters. So to solve it, find the v, you will get the same early answer, that is 2.68 meter per second. So here we are able to do either way, by using energy equations or by using equations of motion and Newton's second law. So you can use Newton's second law and equations of motion, mainly equations of motion when the object has constant acceleration and moves on a straight line. Otherwise you can't use it. If the object is moving on a curved track, you can't use this second method. Only equations of motion. So equations of motions is more useful because if an object is moving on a curved ramp, there you can't use equations of motion, you have to use energy equation. I'll do the question like that also. Okay, so this question I am not writing, but I'll tell. A trolley of mass 200 grams is allowed to move on a curved track from rest. When it reaches the bottom of the track, which is 2 meters below the initial position, so it has moved vertically down 2 meters, find the speed of the trolley when it reaches the bottom of the track. So it's moving on a curved path. So here you can't use equations of motion because it's moving on a curved path. Direction of motion is changing. So the only possible thing, whenever there is change in direction such as moving on a curved path, we have to use only the energy equations. You can't use, so far I used both methods, either energy equations or equations of motion with F equal ma, but here you can't use equations of motion because the direction of motion is changing, acceleration is changing, so you can't use it. Only possibility is by using energy equation. So here the simple thing is loss in GPA, no friction, nothing is mentioned about the friction, maybe a smooth curve, we'll take it as smooth curve, smooth track, nothing is mentioned in the question, so we should take it's a smooth track. So loss in GP equal gain in kinetic energy, or we'll take a friction also, it's okay, I'll put a friction. So the friction acting on the track, okay, I'll include a friction also. So friction, I'll put it a little harder, friction acting on the track during the motion, that is 1.6 Newton, and the total length of the track, I am not writing, I'll show it on the diagram. Total length equal 4 meters. Okay, I'll change the question now. Total length is 4 meters. Okay, so I'll tell the question again. A trolley is released from rest on a curved track at a height of 2 meters above the bottom of the track. Find the speed of the trolley when it reaches the bottom of the track. The speed, the track total length of the track is 4 meters and the friction acting on the trolley during the motion is 1.6 Newton. So here loss in GP equal gain in kinetic energy plus work done against friction. Okay, so loss in GP, it has moved vertically 2 meters mgh, half mv squared minus half mu squared, anyway u is 0, they are telling it, and friction into distance moved, distance is 4 meters along the track. So mass of the trolley is 0.2, mass of this is 800 grams, sorry, it's not 200, it's 800 grams. So 0.8 into 9.81 into the vertical height it moved is 2 meters minus, equal to half into 0.8 v squared minus 0, it was at rest initially. Then work done against friction, friction force is 1.6 into distance moved is 4. So everything you know, find the v, that will be equal to 4.82 meter per second. But here you can't use equations of motion because the track is a curved one, acceleration is changing. Okay, a small sphere of mass 200 grams. attached to an inelastic string, a light inelastic string of 1.5 meters, and the free end is attached to a horizontal peg or nail. The string is initially kept in horizontal position under tension and release. So it moves on a circular path, half, 1/4 quarter circular path, and the question is, find the speed of the sphere when the string becomes vertical direction. So the sphere is moving on a curved path. The question is, find the speed of the sphere when the string becomes vertical. It will move further up, but the question is, what will be its speed when the string becomes vertical? Here also you can't use equations of motion and F equal ma, because the motion is on a curved path. So the only possibility is energy equation. There is no other way. So energy equation, if I use, I can say loss in gravitational potential energy equal to gain in kinetic energy, loss in Gp mgh equal half mv squared minus half mu squared. Okay, so here one thing you can say, there's nothing mentioned about the friction. All the m are going to get cancelled. Important conclusion, I can say, whatever the mass I attach here, the final speed is going to be the same. Remember that they can ask, does the speed depends on the mass? No, because no friction. So there is no other equation. This is the only energy equation I should write. All the mass will get cancelled. Even though they're giving 200 gram, I'm not going to use it because m will get cancelled. And we know u equals 0, it's released from rest. So gh is equal to half v squared minus 0. So it's independent of mass. Whatever the mass you attach, you will get the final speed the same when the string becomes vertical. Okay, now simply I can write, substitute 9.81. The height it moved vertically, initially here, finally here. So the vertical height, I told that when you are considering loss in GP or gain GP, we need to consider the vertical change in vertical height. So initially here, finally here. So what's the vertical height through which it fallen? It has fallen through vertical height, which is 1.5 meter. That is equal to length of the string. So into 1.5 is that equal half v squared. Find the v. That's going to be 5.42. Okay, so here this question includes momentum and energy together. Also they can join together, merge the question like this. 3 meter length of string is one end is attached to a roof and the other free end is carrying a small soft wooden block of mass 80 gram and it is at rest. A pellet of mass 20 gram horizontally moving towards the wooden block at a speed of 30 meter per second before collision. After collision, they embedded, joined together and moved to a position here. So that means the total mass become 100 gram. They moved on a part of a circle because the string is still there. Move to a position here such that the string makes an angle theta with vertical. The question is find the angle theta. The question is find the theta. That's the question. What is the angle theta, or find the angle theta? That is the question. Okay, first we need to use the law of conservation of momentum to find the speed of the block and the pellet. They have embedded, they have joined together. After collision, what is the speed? We need to find v by using the law of conservation of momentum. Then we need to use energy equation. First we'll use the law of conservation of momentum. So if I use law of conservation of momentum, I can keep it in gram because both lines same mass, 20 gram, 80 gram, final mass is 100 gram. So I'll keep it in gram easy. So that is 20 gram into 30 plus 80 gram into 0 before collision. After collision, they join together. So 100 gram into v. Find the speed v after collision. So the speed after collision is going to be 6 meter per second. Okay, so I found the speed now 6 meter per second. Now the wooden block and the pellet together they are moving until the string makes an angle theta where the final speed becomes 0. Uh, they are not saying final speed becomes 0. The question is, yes, final speed becomes 0. Yeah, there. So the question is, what is the angle theta? So at this position, then they will fall down, they will come back, but the maximum distance they moved or the maximum angle they through which they moved is theta. So where the speed becomes 0. So the question, I need to find the theta. We'll use the energy equation. So when it moves from this position to this position, it's losing kinetic energy. Nothing mentioned about friction. So we can say loss in kinetic energy both together equal to gain in gravitational potential energy. Loss in kinetic energy half. Initial kinetic energy mass is 100 grams, so 0.1. When we are using kinetic energy, it must be in kilogram. Here I did not use because if I divide the whole equation, each mass by 100, each mass by 1000, that 1000 will get cancelled. That's the reason I kept in grams. But when you are using energy equation, mass must be in kilograms. So half into initial loss in kinetic energy, initial kinetic energy minus final kinetic energy. Initial kinetic energy half into mass 100 gram, that is 0.1 into 6 square. We found the speed immediately after collision 6 meter per second. So the initial kinetic energy immediately after collision is 6. So half into mass into 6 square. The final kinetic energy 0, here they come to rest, is equal to mgh. 0.1 into 9.81 into h. Anyway, 0.1 will get cancelled. So h, the height they went up vertically upwards is 1.83 meters. Okay, now physics over. Now we need to use little bit of geometry. I'll draw the diagram again. So the diagram, if I draw, this is their position. They were together. Now they have come to a position like this. So this is total height is 3 meters. This also 3 meters. This height we know. So this height they moved up is 1.83 meters. So this height, so this is the total height is 3 meters because the same string, this is 3 meters. This is 1.3 meter, 1.83 meters. So what will be this height? This height will be 3 minus 1.83. This height, this is 3 minus 1.83. So that will be equal to 1.17 meter. This height is 1.17 meter. So we know this length is 3 meter. This is 1.17. We need to find the theta. Use cos theta. Cos theta equal 1.17 over 3. Find the theta. That's the final answer. You will get 67 degree. Okay, so the question says a car of mass 900 kilogram is moving at a constant speed of 16 meter per second. So that means the engine is on. So there is a thrust, forward thrust is there on the wheels. You know, friction provides a forward thrust, that is F, T, the thrust. But it's moving at constant speed. So the friction opposing the motion, total drag force, the total friction opposing the motion must be equal to forward thrust. We know power equal to, for the engine, if I use power equal to forward thrust into speed, but forward thrust is equal to friction because it's moving at constant speed, no resultant force, no acceleration. So that forward thrust must be equal to friction. So we can use the equation P equal F into V, or Ft is the forward thrust. Power of the engine is given, which is 9.6 kilowatts into 1000. Equal to forward thrust into the speed is given 16 meter per second. Find the forward thrust, that is equal to 600 Newton. Therefore, the friction resistive force also 600 Newton because it's moving at constant speed, no resultant force. Okay, so October 2022 paper, WPH was on IAL paper question 19. There's a diagram given. A cyclist is moving up a slope at constant speed. So that means resultant force is zero, constant speed along the slope. So there's a diagram given. So on a slope, a cyclist is moving. You can't draw a proper cycle, so something like this. Okay, so it's moving at constant speed. The slope makes an angle 4 degree with horizontal, and he is moving a distance of 215 meters at constant speed. As the cyclist pedals, there is a constant forward force. When he pedals, there's a constant forward force on the bicycle, which is 150 Newton. The cyclist travels 215 meters along the slope upwards. Show that the work done by the cyclist. So A equal work done by the cyclist is equal to force into distance moved. That is very easy. Force is given. That means the forward force as the cyclist pedals, there is a constant forward force on the bicycle is 150. So the forward force acting on the bicycle provided by the cyclist is 150 Newton. So 150 into distance moved 215. So that will be equal to 32250 joules. So they asked to show almost 3 into 10 to the power 4 joules. So that is 3.2250 into 10 to the power 4, or you can simply write this one 3.2 into 10 to the power 4 joules. Okay, right, that's A part. B part, same question. The cyclist must do work against the force of gravity and air. Calculate the work done by the cyclist against air resistance. That means they ask you to find the work done against friction. Mass of the cyclist and the bicycle together, total mass is given 90 kilogram. Okay, so here the cyclist is applying a force and he is moving. So we know the work done by the cyclist. So work done by the cyclist, work done by the cyclist so work done by the cyclist is equal to, it's moving at constant speed, so no gain in kinetic energy. They are saying the first line of the question number 19, cyclist is moving up a slope at constant speed, no change in speed, no change in kinetic energy. So he's gaining gravitational potential because he's moving up. So gain in GP, gravitational potential energy plus no change in kinetic energy, work done against friction. We need to find this one, work done against friction, we need to find it. Okay, so work done by the cyclist, we already found it, 32250, we know that. Gain in GP, mass of the cyclist given, gain in GP means we need to find the height he moved, this h we need to find. In this right angle triangle, sine 4 equal h over 215. So h will be sine 4 equal h over 215. So h is equal to 215 into sine 4. So we need to use this as a h. So here gain in GP is equal to mgh. That is mgh. Mass of the cycle is 90 into 9.81 into h means that is 215 sine 4 plus work done against friction. I'll put W FR, work done against friction. I need to find that one. That's all. So everything we know, find that one. So that will be equal to work done against friction. That you will get 1.90 10 to the power 4 joule. Okay, this is also Edexcel IAL past paper question, but I can't remember the year. So it says, I am not writing the question. The diagram shows a lift system for moving people up and down a tall building. There is a counterweight. This is the counterweight. There is a counterweight to balance the weight of the lift. An electric motor is used to raise and lower the lift. So there's a counterweight. This is the lift cage. There are people. This is the electric motor. So they are saying there is a counterweight to balance the weight of the lift. An electric motor is used to raise and lower the lift. A part, explain how the counterweight affects the amount of work required from the electric motor to raise the lift. Lift means the lift cage. Again I am reading. A part, explain how the counterweight affects the amount of work required from the electric motor to raise the lift. Okay, so here we'll first think, if there is no change in kinetic energy. Imagine a simple situation. If there is no counterweight and if it is moving at constant speed, imagine no counterweight and the lift cage is moving at constant speed, means there we can say work done by the electric motor equal gain in GPE of the lift cage with the people. So whatever the height, say for example, total mass of the people is 800 kilogram and moving through height of, for example, 6 meters. If you calculate, this much of work must be done by the electric motor. If it is moving at constant speed, I assume there is no change in kinetic energy. This is the required work done by the electric motor to lift 800 kilogram of people and the lift cage together totally through a height of 6 meters. But if there is a counterweight, what's the advantage? Now the counterweight is moving down, it's losing the gravitational potential energy. So the counterweight is attached to the lift cage. So there we can write, whenever there's a counterweight, the equation will be like this. Earlier, work done by the electric motor equal gain in GP. Now we'll see loss in gravitational potential energy of counterweight, because the lift cage is moving up, plus work done by motor equal gain in GPE of the lift. Earlier, gain in GP of lift is equal to work done by the motor. Now, for example, if the gain in GP, for example, again 800 kilogram total mass of the people and the cage together 9.81 G mgh 6 meters. This is the total energy required to raise 800 kilogram of people and the lift cage through height of 6 meters. So this energy earlier, when there is no counterweight, was completely given by the electric motor. Now it's going to share by electric motor and the loss in GP of the counterweight. So that advantage, the work required by the electric motor will decrease because the total required energy to gain GP of the lift cage and the people will be shared by counterweight also. That's the answer you should say. Again I am telling, the work done by the motor will decrease because the total work required to gain in GP of the lift cage will be shared by both work done by the motor and the loss in GP of the counterweight. Therefore, the work done by the motor will be less or decrease. Okay, B part. B part they are saying, the electric motor raises the lift through a height of 40 meters. So the height is given 40 meters during a time of 30 seconds. So the height also given 40 meters. The time duration given 30 seconds. And total mass of the lift and the people. Mass of lift and the people and people, that is given as 2250 kilogram, mass of counterweight mass of counterweight 1300 kilogram. The question is, show that the output power of the electric motor. So we need to find the output power of the electric motor. We'll find the work done by the electric motor divided by the time. Time is given. Okay, so we'll substitute here loss in GP of the counterweight, that is mass of the counterweight, GH. That's a loss in GP. I'm using this equation again. Loss in GP of the counterweight. Work done by the electric motor, we'll say work done by the electric motor VEL, that's electric motor work done, is equal to gain in GP of the lift. Mass of the lift is mass of the lift into G into mgh. H we need to H also given, right? Substitute it. So mass of the counterweight 1300 into 9.81 into 40 plus work done by the electric motor, we have to find it. Mass of the lift is, lift cage is given 2250, 9.81 into 40. Find the work done by the electric motor. That will be 372780 joules. So power, the question is, show that the power of the electric motor, divide this 372780 divide by time, that is 30 seconds. Time is given 30 seconds. You will get 12,426 watts, approximately 12 kilowatts. Okay, C part. The electric motor dissipates energy of the surrounding 3600 watts. Determine the efficiency. So 3600 watts is dissipated. So what's the total input energy? Total input energy to the electric motor is useful output 12,426 joules, that is I'll put it in watts, or 12,426 total input power. So total input power to the electric motor, 12,426 is the useful output power plus wastage. Wastage is 3600 watts. So the efficiency means useful output power 12,426 over total input power 12,426 plus wastage into 100%. So that you will get 77.5%. That's the efficiency of the electric motor. Okay, so that's all work energy power. I hope it will be useful to you. Okay, right, we'll meet during another lesson. Bye.